Morning, 6th grade. Happy Wednesday. Hopefully you're done with the quiz on the back side. I'll rattle the answers on the top, and we'll work with mental math and the problem solving. Remember how this works. If you disagree with me on any of those, circle them. I'm going to read down the columns today, so we do all the addition, all the subtraction, then multiplication, then division. Okay, remember when we add and subtract, you line them up. When you multiply, you count. And when you divide, you might have to do over, up. Here we go. I added, I got 1.2, 1.6, 6.3, 5.2. I subtracted 0.4, 0.8, 5.7, 0. I multiplied 0.32, 0.48, 0.18, 0.9. I divided. Over, up gives me 2. Over, up gives me 20. Over, up with that one gives me 20. And the last one is just up, so I have a decimal answer of 0.03. All right, if you were circling wrong answers, I did average at best. I think you should have gotten 3 of those I did wrong. Calculations for A, I multiplied, I got $14. Decimal, right twice, 450. Cross multiplication, 3 times 20 is 60, divided by 5 is 12. Kilometers to meters is times 1,000, 5,000 meters. 15 squared is 225, 5 squared is 25, subtract it gives you 200. Divide by 9 gives me 5 times 5 gives me 25. Find the middle number, that's 675. Add, subtract, multiply, and divide 7/8 and 1/2. To add them, I need to have common denominators, guys, so that's 4/8. So 4/8 plus 7/8 is 11/8. That equals 1 3/8. 7 minus 4 is 3/8. I multiply. I would multiply the tops. 1 times 7 is 7. 2 times 8 is 16. Stay, change, flip. Puts the 2 on the top. 4 would go... I would divide by 2, cancels the 2, and gives an 8 of 4. I have 7/4 equals 1 3/4. Problem solving looks like this, guys. They said if you look at this, you could count 1, 2, 3, 4, 5, 6, 7, 8 little pieces. If I did it in 2 by 2s, I'd have 1 here, I'd have 2 here, I'd have 3 here, and I'd have 4 there. That's where they got the 4. If I did a 3 by 3, I'd have 1 of those. They said, how many total squares of any size are on a standard checkerboard? Well, guys, a standard checkerboard is 8 by 8. I don't know if I wrote those right, but it would look like this. But here's what I did, guys. I just went backwards. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So I just continued on. I'm doing the perfect squares. 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. And now I need to add those all up. Okay, so I'm going to look for pairs of 10. 4 and 6 is a 10. 9 and 1 is a 10. I'm up to 20. I have another 6 and 4 here. 30. 14 is 44. Carry the 4. 4, 5, 6, 7, 8, 9, 10, 20. So I think I had 204 squares when I add all the different sizes up. So the key to the thing, guys, was to figure out the pattern of 1, 4, 9, your perfect squares, and then just adding them together the right way. All right, yesterday, guys, we worked with all those different graphs on Investigation 5, and on Monday we worked at being able to convert with unit multipliers. It was just a second way to do those things. Today we're going to get a lesson on scientific notation and using scientific notation to take on some really large numbers. Remember, we work our examples on the back side of that quiz, guys, so have that back side of that quiz set and follow along in your book as I read it to you. Your yellow folder doesn't have any blanks for you to write, but I did give you the chart that'll be in there that you can refer to. It says the numbers used in scientific measurement are often very large or very small and occupy many places written in standard form. For example, a light year is, my goodness, that really big long number. So scientific notation is a way of expressing numbers as a product of decimal numbers and the power of 10. In scientific notation, a light year is 9.461 times 10 to the 12th power. In the table on the next page, we use scientific notation to approximate some common distances. Measurements are in millimeters. Practice reading each number in scientific notation. So guys, they'll give you all these charts here, but the misleading thing is they're measuring everything in millimeters. So how far is 1 mile? I'm going to say it's 1 mile. I might switch it to meters and say it's 1,600 meters. I'm now going to say, how far did I run today? I ran 1,600,000 millimeters. People are going to be like, what's that? Oh, it's a mile. Oh, okay, right? You know, so they give you the things just so you can see scientific notation. All right, let's practice an example. Number 1, there are 8.64 times 10 to the 4th second in a day. Can you write that in scientific notation? 8.64 times 10 to the 4th seconds in a day. So they're just teaching you, can you go English to numerical form, right? Or numerical to standard form. In scientific notation, guys, the power of 10 indicates where the decimal point is located when the number is written in standard form. Consider this number expressed in scientific notation. So they gave that to me. Now I'm multiplying by that number has the effect of shifting the decimal 6 places to the right. So that's the big key when we multiply, guys. You're going to the right the same number of exponents. So now I have example 2. My job is to take 2.46 times 10 to the 8th. Now, you got 2 choices, guys. You can go 2.46, 1, 2, 3, 4, 5, 6, 7, 8, and then fill in your zeros where you put the bumps. Then go back. You obviously have to get rid of your decimal place, and if you want it to look nice, you have to get rid of all these bumps, and then you have to go back and put in your commas, 1, 2, 3, 1, 2, 3, and I have the number. Your second choice is this, guys, and here's what I like to do. I know I need 8, and I know I have 2. Because I got to get behind these 2 numbers. So I'm just always doing subtraction. What's my exponent? 8. How many decimal numbers do I already have? 2. 8 minus 2 is 6. So I just boom, 2, 4, 6. And then I said after the subtraction was 6, 0. So I just 1, 2, 3, 1, 2, 3. It saves the little bump moves for me. After example 2, it says, to write a number in scientific notation, it is customary to place the decimal point to the right of the first non-zero. Then we use the power of 10 to indicate the actual location of the decimal point. So to write 405,700,000 in scientific notation, we begin by placing the decimal point to the right of the 4 and then counting the places. We see the original decimal point was 8 places to the right where we put it. To omit the terminal zeros, we write 4.057 times 10 to the 8. So guys, now you're going the other direction. The key with scientific notation is the decimal always goes after that first non-zero. We're going to work this all year long. So in my mind, you just go like this. Decimal point goes here. How many numbers is this? 3, 6, 7. So it's 4 point. And then I have to write my decimal number till I get to the place where there's not zeros. I don't need to write all those zeros. Times, how many did I count? 7 times 10 to the 7th. But your decimal point always has to go after the first number, guys. Okay, example 4 says, can you compare these? Well, 1.2 times 10 to the 4th compared to 2.1 times 10 to the 3rd. Step 1 when you can compare, guys, is you look at exponents. 4 is bigger than 3, I'm done. If the exponents are, if there's one decimal place like there was, they wrote scientific notation correctly, the exponents always win because it's going to be to the power of 10 more. So they're saying, hey, did you get confused that the 2 was bigger than the 1? No, 4 is bigger than the 3. Okay, then they give you a little something with your calculator, guys. They say scientific calculators will display the results in an operation in scientific notation if the number would otherwise exceed the display capabilities of the calculator. For example, if you multiply 1 million times 1 million, you might get something that looks like they show you in those blue boxes. Most calculators, guys, do not put the one on the right, times 10. They just put the little number up there, and you have to know what that means. Okay, so once again, it's another example to make sure you know your calculators really well as you're working your way through these things. Okay, you got some examples doing those things. I'm ready to start cranking some problems. Let's start with lesson 51, number 3. It says the pattern on a soccer ball is hexagons and pentagons. If the perimeter of the hexagon is 9, what is the perimeter of the pentagon? So guys, we have a 6-sided thing and a 5-sided thing. The perimeter is 9. I have to divide it by the 6. It goes in there one time. I subtract, I get a 6, that's a 3. I'm going to add a decimal, 0, 6 goes into 35. So it's 1.5. Now I take that times my 5-sided pentagon. That's 5, that's 2, that's 5 plus 2 is 7. 1 decimal place, 1 decimal place. It is 7.5 inches in that pattern. Number 4, the store sold juice for 65 cents per can, or 6 cans for $3.36. How much money per can is saved by? So I'm going from the 6-pack down to an individual. So guys, I have $3.36. I'm going to divide it by that 6. Decimal point straight up. Goes in there 0 times, goes in there 5 times. That's 30. Subtract is 3. Bring down the 6. Goes in there 6 times. It costs 56. They asked me how much did I save. So now I have to do 65 minus 56. That's a 9. I'm saving 9 cents per can. So we had one of these questions on the test a couple weeks ago, and a lot of us did this answer. That's how much you save total. They didn't ask me total. They asked me per can, guys. So make sure you're reading those questions very carefully and answering what they're asking for. Number 6, it says write 12 million in scientific notation. Well, guys, we know that a million has 6 zeros. So to write it in scientific notation, my decimal point has to go there. So I have 1.2. Now, how many numbers are that? 6, that's 7. So it's 1.2 times 10 to the 7th. B says write this in scientific notation. They give me 17,600. I know my decimal point goes there, so I have 1.76. That's 1, 2, 3, 4 times 10 to the 4th power. Number 7. Can you do it the other way? So this time I have 1.2 times 10 to the 4th. I did 4 minus 1 digit is 3. So it's 1, 2, 1, 2, 3, comma. The next one was 5 times 10 to the 6, guys. There's no decimal point, so it's just those 6 zeros. 1, 2, 3, 4, 5, 6. Go back, put my commas. That's 5 million. This was 12,000. Good practice going the opposite direction. Number 8, write each number as a decimal. Top in, bottom out. Hopefully you have the answer done already because you have it memorized. 8 goes in there 0, decimal straight up. 1 is 8, subtract 20, 2 is 16, subtract 40 is 5. Have it memorized. B, write that as a 1/2, guys, is 0.5. Now percent left twice, 0.875. That's 7/8, guys. Memorized. Number 12. It says at 6% sales tax rate, the rate is written as a decimal, 0.06 for each dollar. Make a function table to show the sales tax for 1, 2, 3, 4, 5. You got it. So I have my sales tax rate, and I'm just counting by 6 pennies, guys. 1, 2, 3, 4, 5. So that's 6 cents, 12 cents, 18 cents, 24 cents, and 30 cents. Then B says, at the 6% rate, what it will be on 15? Well, I just take 15 times 6. That gives me 0 and a 30. 6 plus 3 is 9. It would be 90 cents. Number 13, Layla is thinking of a positive, single-digit, even number. Lewis guesses is 7. A, what's the sample space? Well, a single digit, positive, even is 2, 4, 6, or 8. That would be A. Those are your choices. What is the probability that Lewis guesses correct? B, that's a big old 0 there, Lewis. You guessed an odd number. She said it had to be even, so he doesn't have a prayer of getting it right. Turning your answer key over, turning the page in your book. Number 16 says estimate the area of the garden in square feet. So we're looking at that chart that they did for 15 and 16. We can see it's chopped like this. So guys, as I write it down, I am estimating. So I took 24 10 inches and rounded to 25. I rounded to 30. I rounded to 20. And I round to 20. Okay, I'm going to chop through this one. I'm not using the 30. So the bottom here is 20 times 25. So if I do 25 times 20, I get 500. 30 got circled. 30's on a vertical line. 20's on a vertical line. I subtract those and get 10. 10 times 20 is 200. Add those together is 700. And you're working in square feet. So don't forget your label. I'll write it over here like you would write it on the side of your answer key. 700 square feet. Number 18, cross multiplication. I have 6 over 4.2 equals something over n. N over 7. So guys, I'm going to go like this. 7 times 6 gave me 42. So maybe it'd be better to think it this way. 42 divided by 6 gave me 7, so 6 divided by 6 gave me 1. But I have this decimal, so it's not 1, guys. It's actually 10. Bigger number on top of a smaller number, bigger number on top of a smaller number. That might have been easier to solve this one through cross multiplication. 7 times 6 is 42, and then 42 divided by 4.2 would have slid that decimal over, and you'd got your 10 that way. So trying to get a feel of what's fastest for me working with the multiplications and things, probably should have done cross multiplication with that one. Number 21, simplify this answer. So I have 5 squared. I just did that in my head and I wrote down 25. Plus 3 times 3 is 9, times 3 again is 27. Plus square root of 64 is 8. Okay, now it's just addition. 5 plus 7 is 12. Plus 8 is 20. Carry the 2. 40, 60, done. 22 from our lesson on Monday. I have 16 centimeters over 1 times 10 millimeters over 1 centimeter. The centimeters are gone. I multiply the top. 16 times 10 is 160 millimeters. The word problem would say, can you switch 16 centimeters to millimeters? And now you know how to do that. 23, I have 8 days, 3 hours, and 15 minutes. I'm subtracting 5 days, 18 hours, and 50 minutes. I love these problems. We got to do all the conversions, guys. So I start with hours and minutes. Can't do the subtraction here. Crossing out this, 2 hours. I'm adding 60. 60 plus 15 is 75. Now I can do the subtraction. 5 minus nothing is 5. 7 minus 5 is 2. I have 25 minutes. Can't do this subtraction. I'm crossing out a day. There are 24 hours in a day. I already have 2, so I'm up to 26. Cross out the 2, make it a 1. 6 becomes 16. 16 minus 8 is 8. That's 8 hours in that day. 7 minus 5 is 2 days. So I have 2 days, 8 hours, 25 minutes, the conversion things. 26. I'm going to make it improper as I write it. So I have 3 times 3 is 9 plus 1 is 10 over 3 times, parenthesis. 3 times 2 is 6 plus 2 is 8 over 3 divided by 2 times 1 is 2 plus 1 is 3 over 2. Division is stays the same, changes, flips over. Multiply the top, 16. Multiply the bottom, 9. Now I'm taking what I have here of 10 thirds times 16 over 9. Multiply the tops gives me 160. Multiply the bottoms gives me 27. I'm going to write this on the next sheet of paper. So I have 160 divided by 27. I think it goes in there 5 times. 5 times 7 is 35. Carry the 3. Gives me 10, 13. Subtract. Can't. 5, 10 is 5, 2. Whew. 5 and 25 27ths. So guys, they gave us a big problem that they didn't let us cancel anything out of, which made it a little bit more difficult. But we got it. Number 27, show 2 ways to evaluate that expression for 0.5 and 0.6. So I have 0.5 times 0.5 plus 0.6. Step 1, your brain would say do parentheses first. So I have 1.1 and then times 0.5 would give me 0.55, because then I multiply, I count my decimal places. Distributive property says multiply first. So 5 times 5 is 25. 2 decimal places equal that. 5 times 6 is 30. 2 decimal places equal that. And then you add and get 0.55. So normally, guys, it's parentheses first and then multiplication. Distributive property says multiply and then add. Doesn't matter. And number 30, when the temperature increases from freezing temperature of water to the boiling point of water, is an increase of 100 degrees Celsius. The same increase of temperature is how many degrees on the Fahrenheit scale? 212 is when it boils. 32 is when it freezes. I'm just looking for the difference, guys. So I get 180 degrees. We'll use that as we create that formula that we've used a few times for Celsius to Fahrenheit. Awesome. We're done with our problems, guys. Happy Wednesday. Why don't you write on the top of your page, almost Christmas break. Put a big old smiley face by it. We're getting excited. Christmas is almost here. 2020 is almost